Okay, so one of the things I like to ask, because it's a good one to talk about, is get you an idea that virtual reality really is a lot like these computer games. Virtual reality is a virtual reality, and they work a lot like we do. The big difference is that our virtual reality is many orders of magnitude more complicated, and it's evolved. It's not programmed. It evolved this way. We went through that earlier, so that's the main difference. But other than that, they're the same. So I asked the question because it's obvious in World of Warcraft or in The Sims, do the programmers have to program oxygen for their players to breathe? Do those elves and alligator men and the rest of those people, they have to have little oxygen molecules made for them by the programmers to breathe? Well, of course not. That's ridiculous, right? They're not real. They're just virtual. It's the same with us. It's the exact same with us. And there's no need to render any oxygen molecules in this room. Not at all. So why are we all here breathing and not falling over dead from lack of oxygen if you don't render oxygen molecules? Well, see, you're caught in a trap thinking that this is a Newtonian objective reality. You're caught in that thought process. We don't need oxygen to be rendered here. We just need to act as if we had oxygen. And why do we all go on and act as if we had it? Because it's probable. This is a probabilistic statistical system. There's enough plankton in the ocean, there's enough trees in the woods, that the probability is that we'll have oxygen. So we do. We act like it. You get rid of the plankton, you cut down all the trees, and the probability is that we wouldn't have it, and we'd all start gasping and fall over. You see, it's just probability and statistics. So only the effects have to be rendered. It's much easier job computationally just to render effects. Nobody has to render all the underneath causes. Now, does that mean that when you go to sleep at night, all the world disappears? No, the world was never there to begin with. It's all just virtual. You see, it doesn't disappear. It's just no longer being rendered for you. There's other people in the world, and they still see it's being rendered for them. It's not being rendered for you. So you can't make the things you don't like go away just by closing your eyes, because they're still there being rendered for others. So there's a tree in a park, and everybody goes to bed, and then nobody on the street. There's a tree in the park. All just disappear. It's the wrong question. Reality is not objective. It was never there in the first place. It was just data being rendered to individuals and mutual individuals. So you get up the next morning, you open the window, and you look at the park. There's that tree. There's that park. Now it's being rendered to you. You see? It wasn't rendered to you before. Doesn't mean anything goes away. That's just a habit of thinking that this is an objective reality and that stuff actually exists. Remember what Bohr said? He said that if you think that the stuff that's out there is real, then you haven't really understood quantum mechanics yet. It's not. It's just a virtual reality, and it's in your head. All right, another one that I like a lot, you've probably heard me say it if you've listened to the YouTube, but it's fun anyway. If a tree falls in the woods and there's nobody there to hear it, does it make a sound? And of course, the same thing that we've just been saying, it's all virtual. There is no tree. There's no woods. There's no sound. It's all statistical. So how does that work? Well, the guy walks into the woods and he sees a wobbly tree standing up. So here's this tree, and it's not falling over, it's wobbly. Now, why does he see a wobbly tree? Because that's a probable thing for him to see. Could he have seen something else? Sure. There was probably 50 things that would have been not any conflict with those two rules I said. No conflict with the rule set, no conflict with historical consistency, because this was a virgin woods nobody had walked into before. So there was no pictures laying around of that part of the woods or no surveys done. So there's lots of uncertainty there. Where there's lots of uncertainty, there's lots of choice. Okay, so there may have been 50 different things he could have seen. So what happens? You reach in and you grab a random draw out of the probability distribution. Comes up a dead tree standing there wobbling around. So that's what he sees. So now he walks out of the woods, comes back 5 years later, and he sees a tree laying on the ground. Why? Because 5 years later, it's probable that tree would have fallen over. So it gets rendered to him lying on the ground. Did it fall? No. It didn't even exist. Never did exist. It got rendered because it was probable wobbly. It got rendered because it was probable laying down. It's just because you believe in an objective reality that you think it had to fall from one state to the other, because you think it's real and it's out there, and it's not. So see, that's how probability works. Now let's say the guy saw the wobbly tree. He goes out of the woods, and he takes 2 steps out of the woods, he gets eaten by a bear. No. The information's gone. The information's no longer here. He made the measurement, right? He saw the tree, but now the information's just been erased. So let's say right after he gets eaten by a bear, the bear walks off, and another guy walks into the woods. Does he see that same tree? Maybe. Probably not, because there's probably a lot of different things it could be, and there's no history that says it has to be a dead tree there, or a wobbly tree standing there. He could walk into that woods, and there would be no wobbly tree there. See, it doesn't matter, because that wouldn't violate any consistency. There's no record that violates the consistency of that historical. There's no reason why, by the rule sets, you couldn't have a live tree standing there. So you get a different picture. But now, once he leaves, let's say he's in there and he takes a picture of the woods, and he leaves, and anybody else comes in there, are they going to see the same thing he saw? Yes. Why? Because the measurement's been taken and the information is available. See how we have the same thing as a double slit? Why? Do we see the double, why does the double slit work that way? Because when you take the measurement of what slit goes through and you have that data available, then you get just 2 spots. You don't get a diffraction pattern, because now that would be inconsistent with the history. The history says, I know that a particle went through that slit. Well, then a particle has to go through the slit, and you got 2 spots. But if you erase that data before you look at the result, even though you took the data, you throw it away, you burn it up, and then you look at the result, now you get a diffraction pattern. You see, because what matters is whether or not there's an inconsistency in your reality. No inconsistency, no problem. Now this gives the system multiple solutions to any problem. So if you've got if you're making choices or whatever, and you're doing measurements, right? We're making a choice, we do something, some measurement. There may be 10 different ways that could come out without any conflict in the system. Still abides by the rule set, historical consistency. So which one of those 10 are you going to get? Well, it could just be because you randomly draw out one and that's the one you get. Or the system may say, I think if it came out this one, that would kind of give you a wake-up call. That would really help you in your time of need. That would be something that would be useful to you as far as your growth goes. That's called synchronicity. Things just happen when you need them. Things just are there, just at the time and the place that just is right for you, and it's, we call that synchronicity. So the system is actually trying to help you. And it can do that if you're open to the help. If you're not open to the help, then there's no point. Because if you're not open to the help, why would it bother? It's not going to do you any good. But if you're open to the help and you say, gee, that was really amazing that, look at this line of incidents that happened to me. I just went to here, to here, to here, and then bingo, there I was. That's hard to believe that was just, random. And it could be random. It could just been luck the way it played out. But it doesn't have to be. You see, there is a possibility that the system can manipulate those things to nudge you. Now, it can't make choices for you, but it can give you opportunities to make good choices, to see things, to look at a bigger picture. That's what it can give you. But you still have to make the choice, do whatever it is you do. So the system is really trying to help you out if you let it. If you want more help from the system, then put yourself in a position to learn from it, and you'll get it. Put yourself in a position that you won't learn anything no matter what happens, and you won't get any of it. Okay, so that's some good advice. Okay, so uncertainty provides wiggle room within the constraints, of the sign certainty in the rule set. So that's how all this relates back to the double slit. You see, the double slit experiment's not just about little things, like physicists will tell you. That's just in the world of the tiny. The reason it works in the world of the tiny is because in the world of the tiny, there's lots of uncertainty. Okay, you got electrons zipping around or a photon running around at the speed of light. Where is it? It's hard to tell, It has this huge uncertainty in its position. Well, there's so much uncertainty in position that the probability of where it might be, you see, can go across both slits. So it can go through probability, can go through both slits. That toaster oven, where it is, has a teeny little, probability of where it is. We know where that is because that's a big thing we can see. So it's such a tiny little uncertainty that it can't do that. See what I mean? So that's why we think that quantum mechanics only applies to little things. But see, the bear in the woods and the tree, quantum mechanics. The same quantum mechanics that this double slit applies to our everyday life. Our whole reality is like that. It always bothered me when I was in graduate school that quantum mechanics only applied to little things. It's like, why is that? Why do you have a general rule of physics and it only applies to little things? If it's a general rule of physics, it ought to apply to things. It ought to apply the same to everything. It's not like, well, here's a rule. Well, are you too big for me to apply to you? Are you a big thing? Sorry, can't apply to you. That doesn't make sense. Physics generally doesn't work that way. If it's a rule, it's a rule. It applies. And this thing, well, it only applies to little things. What it applies to is things that have uncertainty. Well, we have lots of things in our life that have uncertainty in them, don't they? We probably have more uncertainty than that electron has in its position with a lot of things that we do. And in all those things that are uncertain like that, like what you're going to find when you walk into a woods, a lot of uncertainty there. A lot of things can happen. We live in a probabilistic, statistical reality. And that means that strange things can happen. That means that we can have things like synchronicity. That means we can, take a 2-hour drive in an hour. And somehow we just get home and we don't know how it was. That was impossible, but it happened. Things like that happen, and they can happen as long as they don't violate those rules. So you'll live in a really squirrely world. And that's the way that is. Speaking of squirrels, let's say that tree that was wobbly had some squirrel nests in it. Okay? Let's say some squirrels lived in that woods. So squirrels live in that tree. Now, the guy goes out, gets eaten by a bear, and the next guy comes in. Is he going to see the same thing? Yes. Why? Because it's a multiplayer game, and those squirrels are part of the game. Their consciousness. In their mind, they have that tree mean something to them, that it exists there like that. And you're not going to come in and not find that tree. The tree has already come into this reality through a measurement of squirrel consciousness. Now, squirrel consciousness isn't like people consciousness. So it only has to come into this reality to the extent that a squirrel sees it. To the extent that a human sees it, it's entirely different. See? So there's lots of things that are uncertain. So maybe there's this great big old tree and it's down in your Central Park and it's been there for 200 years. Everything's pretty well known about it. It's always going to be there. It's always going to look the same. The roots are always going to look the same. Lots of people have seen it. Lots of people have taken their pictures next to it. But what about way up at the top where nobody's ever been? Is there a bump up there or not? Well, you go up there and take a look and make a measurement. And there may be just as equal probability that there is one as there's not one. You got a 50-50 chance. You might get one or the other. You see, it's not an objective reality.